Welcome to Bending Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask us questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Bending tutors. Excellence is our word.
Hello amazing ones, welcome once again to Bending Tutors YouTube channel. Yes, a channel where we upload content you can learn from. Are you watching this video for the first time and you're yet to subscribe to our channel? Please pause and click on the subscribe button right away before it does not bite. Thanks as you do so. Alright, welcome to physics class, and the topic we'll be treating today is friction. Yes, friction. Though we'll be focusing more on calculations. We won't be doing much explanation. So we'll be doing much explanation. So we'll be focusing more on calculations. So we just want to show you what friction is. In case you don't know what friction is, maybe this is your first time of seeing the word friction. So that is why we want to explain it briefly. Then we're moving fully into calculation. Alright. So now what do we mean by friction? Friction is the force which acts at the surface of separation between two bodies in contact. Like this body. The body here is what my two ends, okay, in contact, and tends to oppose the motion of one over the other. Now, on a norm now, as I'm rubbing my hand now, my hand is meant to be slopey, okay, but it's not slopey. You get it now? But instead, friction appears whenever I rub my hands, and my hand becomes hot. Whenever you rub your hand and your hand becomes hot, it shows that what friction is, what friction has taken place. Okay, whenever you rub your two ends and you are feeling, and your hand, you are feeling heat in your hands, that's what we call friction. So that friction has taken place. You get it now? But whenever you rub oil in your hand and you are rubbing it, it will look sloppy. So friction has not taken place. Okay, so there's no friction, there's no presence of friction whenever you apply oil in your hands and you're rubbing it. So there's no presence of friction. Are you getting it now? So now what makes you to walk without falling down, all right, without slipping? What makes you to walk without slipping is friction. Are you getting it now? What makes you to walk without what slipping is friction. But you can imagine when I pour oil on the floor, when I pour oil on the floor now and I walk on it, it might be like, what happens? I will slip. That shows that there's no presence of friction. Are you getting it now? So what makes you to walk without falling is what, without slipping, is what? Friction. Are you getting it now? So what makes you to rub your two ends and you are feeling it? That shows that there's a presence of friction. Alright, so friction opposes motion. Friction opposes motion. Are you getting it now? So also friction is the opposite of motion. Now when I draw this what, when I move this chair now, when I move this chair to the front and it stopped, friction has taken place. Friction makes it to stop. Are you getting it now? So when I move this chair and it wasn't slipping. Are you getting it now? It wasn't slipping. When I move this chair, it's not slipping. It shows that there's a presence of friction. What makes it to stop is what? Friction. Do you get it now? So now let's just look at this diagram. So now we have we have the wooden block, and we have what? A pulley. Maybe we have something that is pulling it. Are you getting it now? So now this is a table. You get it now? We have a wooden block and this particular force pulling this wooden block. So we have the reaction. R is the reaction of table on the block. Okay? And then this is the weight. The weight is the wooden block itself on the table. Okay, so when you are pulling it, are you getting it now? When you are pulling it, friction is taking place. Get it now? This is the force. This is the wooden block, which is the reaction of table on the block. The reaction of table on block So this is what P, which is what the effort or what force producing the motion. This is what is pulling the wooden block. I get it. And this is the table, and this is the weight. Okay. So I just want to show you this diagram because when we start with some calculations, you won't have issue with all this F, R, P, W. Are you getting it? Because we what it will be part of the what the things you'll be seeing in the calculation. So let's quickly what dive into the calculations fully. So this is a diagram. So it said the diagram above illustrates a body of mass 5 kg being pulled by a horizontal force. Okay, if the body accelerates at 2 meters per second square and a frictional force of 5 Newton, we have to calculate the net force, the magnitude of the force, and the coefficient of the what kinetic friction. So now let's start with the first one, which is the net force. Okay, so the net force is also called resultant force, which is Fr. So get it now. So the net force is also called the resultant force. The resultant force, which is what Fr. Are you saying it now? So the formula for Fr is what mass times acceleration. Are you getting it now? So now what is our mass? Let's write out our data. We are given the mass to be 5 kg. Alright. So now if the body accelerates, acceleration is what 2 meters per second square. And the frictional force Fi is frictional force, okay? Frictional force is 5 Newton. So now let's find the resultant force or the net force. So that would be Fr equals to, our mass is 5 and our acceleration is 2. So our resultant force or the net force is 10 Newton. Remember, the unit for Newton is 10. Okay, know that, get that now. So the magnitude of F now. So when you talk about magnitude is also called applied force. Magnitude force is also known as applied force. Alright, so applied force is denoted by P, okay? So now the formula for that is P equals to the resultant force plus the frictional force. The frictional force, P is the applied force, so it's also known as the magnitude force. So from here now we can now get our magnitude force. So we already know what our resultant force is. Our resultant force is 10 Newton and our frictional force is 5 Newton. Okay, so now let's apply it here now. So to get our magnitude or applied force, our resultant force is 10 and our frictional force is 5. So that gives us 15 Newton. So we've gotten our magnitude or applied force. So we have to get the coefficient of kinetic friction. So our coefficient of kinetic friction is frictional force over the normal reaction. Are you getting it now? So our normal reaction is also equals to weight. Our normal reaction is also equals to weight, and the formula for weight is mass times acceleration, which is mg. Okay, are you seeing it now? So what is our frictional force? Our frictional force is given as 5. Alright, so now I want to get our weight now. That will be weight equals to our mass times which is 5, times our acceleration due to gravity, which is 9.8 or 10. So that gives us 50. Alright, so our frictional force is 5. So the coefficient of kinetic friction equals to 5 over 50. So that will give us 1 over 10 or 0.1. Alright, or is 0.1. So the answer is is 0.1. So that is for the first question. So let's solve another question now. It is very easy once you know the formulas, okay? They said a block of wood of mass 5 kg, okay, is pulled on a platform by force of 40 Newton, alright, as illustrated in the diagram above. If the frictional force experienced by block is 12 Newton, we have to calculate the magnitude of the acceleration of the block, which is A. That is what we're looking for. So let's do that now. So to solve the question, we already know that our resultant force, or the magnitude force, okay, is MA. Are you seeing it now? So to get our acceleration, we're going to divide both sides by M. So our magnitude acceleration, okay, the magnitude of our acceleration, A is Fr over m, which is the resultant force over what? Over mass. And as you can see, we are not given the resultant force. So let's write out our data. So now we are given the what? The force applied, which is the applied force, which is P. Applied force, which is P, which is what? 14 Newton. Are you seeing it now? So we are also given the frictional force, which is Fi. Applied force is P. Don't forget, frictional force is Fi, which is 12 Newton. So we are not given the resultant force. So what are we going to do? We use the formula. Applied force equals to resultant force plus frictional force. So now for us to get to resultant force, so we're going to collect like terms. So that will be P minus Fi equals to Fi. Okay, so that is how we are going to get the resultant force. So now, what is our P, which is the applied force, is 40. Our frictional force is 12. Equals to Fr. So our Fr equals to 28 Newton. So we've gotten our what? So we've gotten our what? Our resultant force. Resultant force. From here now we can now get our what? The magnitude of the acceleration, which is A equals to resultant force, which is 28 over our mass. Our mass is given as, sorry, I didn't put it, 5 kg. Alright, so when we what? 28 divided by 5 will be giving us what? 5.6 meter per second square. So simple as ABC. So that is our answer. If you have any question, do well to the comment section below. So let's solve the last question for today. Alright, amazing students. So this is another simple question that I want to smash. Alright, said a block is acted upon by two horizontal forces. These are the what? Two horizontal forces as illustrated above. So the block accelerates at 1.5 meter per second square. So we have to calculate the mass of the block. And these are the options, and one of these options is correct. So, alright, so let's quickly solve it. As we all know, this is the what? This is our force, this is the applied force, this is the frictional force, and this is the applied force. So now let's get that now. So for us to get our mass, we'll be using this formula, resultant force equals to ma. So to get our mass, we divide both sides by what? By a, which is the acceleration. So our mass equals to the resultant force over the acceleration. So now if you can see, now let's write out our data. This is the frictional force, and that's why I show you the diagram, the previous diagram when I was explaining friction. So the frictional force is always here, the applied force is always here, which is a P. So this is our frictional force, which is 1 Newton, the applied force, which is 10 Newton. As you can see, the resultant force is unknown, so we are going to get it using this formula, which is P, which is the applied force, equals to the resultant force plus the frictional force. Okay, so that is how to do that. So simple. So now to get our resultant force, we are going to make the resultant for the subject. So that will be P minus Fi. So this plus Fi will move to the other side. So when this plus is moved to the other side, it turns to negative. That will be negative Fi equals to resultant force. So what is our applied force? 10 Newton. What's our frictional force? 1 Newton. And so that gives us 9. So our resultant force equals to 9 Newton. From here now we can get our what? Our mass. So our mass equals to our resultant force, which is 9, over our acceleration. So our acceleration is given as 1.5 meter per second square. So that will be 1.5. So 9 divided by 1.5 is what? 6. So our answer is 6 kg. So simple as ABC. Yes, as you can see, the most important thing is what? You knowing the formula. So once you know how to apply the right formulas, then you are good to go. Physics is very simple if you know how to apply the right formulas. And one thing about physics is there are always formulas are always coming together. You get it now. So there are always it's from one formula to another. You get it. So you have to learn to be able to memorize formulas in each topics. Okay, so now this is where I'm going to be stopping for today. So in the next video on physics, we'll be doing another thing entirely. So those who watched through to this period, thanks so much. We're so grateful. Are you watching for the first time and are here to subscribe? Please do well to use the subscribe button right away before it does not bite. Thanks for watching. Bye.